Hello students, today we will be going to do a new topic which is an electric dipole. Electric dipole, it is denoted by a symbol of P. Okay, now whenever a process like induction or polarization happens, then the dipole is created. Like suppose a charge comp, suppose here I have a comp, let me just represent comp, which may be charged by rubbing it against the dry hair. Okay, now when a charge comp is placed near to the piece of paper or hay or straw, okay, any light thing, then what happened, that it get attracted to it. Now why it get attracted, then we can answer that is because of the process which is known as induction, right? Now in this case, when the comb is rubbed against the hair get one charge, the comb gets another charge. I don't exactly remember. Say it gets plus charge. Okay, let's say the comb gets plus charge. That means the hair gets the negative charge. When it is placed near the paper, then what happened? Because of the induction, the side of the paper will get slightly negative, while the other side of it will become slightly positive by the equal amount, and this is known as the induction, or this is known as the polarization. Okay, now the distance of few centimeter or micron also makes the difference, because we know that the Coulomb's force is inversely proportional to the square of the distance, so it makes the difference. So in this case, as the as the negative induction is nearer, so what will happen, the bits of paper, it will move towards the comb. As it is lighter, so it is. So whenever the induction happened, all polarization occurs, there comes a thing which is known as a dipole. So we say dipole is created. Even in chemistry you have learned about electronegativity, like say for an example HCl, then we say it is electronegative because what, it is slightly polarized, this, right? Okay, so here the distribution of equal but opposite charge separated by some finite distance, this is known as electric dipole. We are talking about the charge, that's why electric dipole we are saying. So say suppose here is minus q, we are doing in general form, and here is plus q. The magnitude of the charges are the same. However, these two charges are separated by some distance. Here in your text, as they use the distance 2L or 2A. So the system of equal and opposite charges separated by some distance, this is known as a dipole. Now you might be thinking why I have chosen 2A. First thing, your text have chosen. Another thing, we are taking all the measurement from the center. So from this side A, that side A, so A plus A, 2A. Okay, so whenever there is a dipole, that means this type of system, then with the dipole we associate one thing. So what is a dipole? System of equal and opposite charge separated by certain distance. Like this is a dipole, here also dipole is formed. Okay, now with the dipole there is one thing which is known as a dipole moment, which you need to know. Okay, now what is a dipole moment? See, the symbol for the dipole moment actually is P, not this one. Okay, electric dipole is simply the system. Dipole moment, with the dipole, the quantity which is associated is known as a dipole moment. Okay, now dipole moment, it is a vector quantity. Okay, and it is defined as, I'll write in terms of magnitude, it is defined as the magnitude of either of the charge Okay, I wrote magnitude because it can be minus, it can be plus, all total it's 0, right? So magnitude of the either of the charge into the distance between the two charges. Sorry, here we are using A, right? Okay, so dipole moment is defined as the product of the magnitude of the either of the charge and the distance between the two charge. Now, as I have already said that it is a vector quantity. Now, charge is a scalar quantity, so what can be a vector? Distance is a vector in this case. Okay, so it will be no longer a distance, basically it will be a displacement, right, in this case. Now, what is the direction of the dipole? See, direction of dipole, as it is a vector quantity, the direction of P is along, always remember, is along a line, and this is along -2 plus Q, right? Clear? Okay, so it will be along -2 positive. You have to keep in your mind. Now, in this case, this system possesses the dipole moment, and what is the direction of the dipole moment? Along here, along this line, right? Then what is the magnitude of the dipole? Magnitude of the dipole is Q into 2A. Okay, now with this we can do some question, easy questions we can do, right? Like suppose I have taken, let's say here is 2 microcoulomb charge, and here is, as we are saying about the dipole, so this is -2 microcoulomb, right? What is the net charge of the system? What is the net charge? Then what is the net charge? This is 0 because +2 and -2 cancels out each other. Let's say they are at a distance of, let's say, 10 to power -6 meter, that is 1 micrometer. See, whenever polarization induction occurs, the distance cannot be large. That's why I'm using such a small unit here. Okay, now the question is, how much is the dipole moment? All right, now dipole moment I'm showing by a symbol of P. Now what is the dipole moment? Dipole moment, as it is defined as magnitude of the either of the charge and the distance between the two charges, right? Now I have chosen this as an origin, right? Then this distance will be how much? This distance will be half of 10 to power -6, and this will be what? Half of 10 to power -6. That means basically we are choosing this distance. This distance is already, we know, 10 to power -6. Why to bother about? Remember, this 2 has come in the formula is because we are choosing the origin at the center. Okay, all the texts have done, so we are doing the same. Now, what is the dipole moment? Now I'm just finding the magnitude, so I have removed the vector sign. Now, either of the charge, so this is 2 micro means what? 10 to power -6, right? Into how much is the distance between the two? The distance between the two is how much? 10 to power -6. Don't put 2 as we are choosing the origin here. Okay, I'm repeating as so. Dipole moment is how much? 2 into 10 to power -12. Then what should be the unit of the dipole moment? Coulomb meter, right? So coulomb meter. Don't write cm, otherwise it will be centimeter. C should be bigger, m should be smaller. Okay, so this is all done. Now what about the direction of the dipole moment? Direction of dipole moment is along -to positive. Okay, so I hope it is clear about the dipole moment.